Hey guys, let's go ahead and do the last video for this unit, and we're going to be talking about gas laws. So first let's talk about the density of a gas. Now the density is how much mass we have in a certain amount of space. So if we keep the mass constant and decrease the amount of space, then the gas becomes more dense. I hope you are not hearing them cutting the grass behind me, but if you are, I apologize. If we increase the mass and keep the amount of space constant, then the gas also becomes more dense. So remember that mass is amount of matter, right? So if we keep the mass constant and we increase the amount of space, then the gas becomes less dense because you're giving it more space to move around. And if we decrease the mass and keep the amount of space constant, then the gas will also become less dense. Now remember, our little molecules represent our mass, right? So if you'll look at your picture, the atomic windows, that's what they're called because it's like you're looking into an atom. They represent particles of the same gas occupying the same volume at the same temperature. The only thing that's different is the number of gas particles per unit of volume. So the only thing different is the mass. So I want you to take these three pictures and I want you to label them least dense all the way to most dense. I want you to pick out which one is least dense, which one has the middle density, and which one is the most dense. Okay, I want you to pause this and go ahead and label that. Now we'll talk about the answers tomorrow to see if you are correct. Now there are three properties of a gas that we're going to be addressing when discussing how they behave, how gases behave. The three properties are pressure, temperature, and volume. When we discuss the relationship between these properties, there is always going to be one that remains constant. We can't change all three at the same time. So one will always need to remain constant when we're discussing how they affect one another. Now, if temperature remains constant, if we're keeping temperature constant, if we increase pressure, our volume will decrease. So look over here at our picture. We have pressure increasing from left to right. The highest pressure is at number 3. The least amount of pressure is number 1. Do you see that we have more volume in number 1 than we do 3? So when you increase pressure, you decrease volume. Okay? If we decrease pressure, we increase volume. So that means that pressure and volume are inversely proportional. They're opposites of one another. When one increases, the other decreases. Okay? And the opposite is also true. If your volume increases, your pressure must decrease. If your volume decreases, your pressure will increase. And you need to be familiar with how to read this on a graph as well. Now, let's talk about if we keep pressure constant. If we keep pressure constant, if temperature increases, the volume will increase. Because remember, temperature makes the molecules move more. So when they're moving more, they're going to increase their volume. If temperature decreases, volume will also decrease. And that means that volume and temperature are directly proportional. Because the opposite is also true. If volume increases, temperature will increase. If volume decreases, temperature will decrease. Now for the last one, let's keep volume constant. And if we keep volume constant, then if we increase temperature, then we also increase pressure. So that means that temperature and pressure are also directly proportional. When one of them increases, the other increases. When one of them decreases, the other will decrease. All right, so that's the end of our video. So I would like you to summarize by doing this. I want you to write the letters A, B, and C. A, B, and C. And I want you to write a word or sentence that starts with each one of those letters that tells something that you learned in this video. I hope you have a great evening, and I'll see you in class.